Hello friends, topic of this video is hashing technique. So in this video, first we will learn about what is use of hashing, what is ideal hashing, and what is modulus hash function and its drawback. Then we will discuss about its solution. So let's start one by one. So first question is why we need hashing. So just take example. We have keys as already given. So hashing can be used for searching, but as we know, some known technique like linear search, binary search, we already know about this. So linear search means when the keys are given and it is unsorted, we can traverse it and we will find a key. Then it is linear search. Then next is binary searching. For binary search, keys should be sorted order. So first constraint is it should be sorted. Then we can apply binary search. For linear search, time complexity is big O of n. For binary search, time complexity is big O of log n. But in hashing or via hashing, we can achieve searching in constant time complexity. So what I mean to say, for linear search, it will take log n time complexity. For binary search, it will take, linear search, it will take log big O of n time complexity. Binary search, it will take log n time complexity. But via hashing, we can achieve is via constant time complexity. This is for linear search, this is for binary search, and this requires sorted. We can apply binary search only on sorted order, and it can be sorted and unsorted. Both type of keys are there when we can apply linear search. But this is hashing. But let's take hashing. So for that, if the keys are given, we can map key to their space, like indexes we can map one by one. Okay. So if we want time complexity less than log n, then via hashing we can achieve it in big O of one time complexity, means constant time complexity. For that, idea of hashing technique is introduced. So we want to search the key less than log n, means big O of n, means almost constant. So this technique is used. If keys are not sorted, then we can't apply binary search. This is the constant. For sorting, we already learned about this merge sort, heap sort, quick sort are there. For that, and log n is a time complexity. When keys are unsorted, first we have to sort it, then apply binary search. Okay, but via hashing we can achieve it in big O of one time complexity. Means hashing is fastest searching method. But let's see how we will hash it. Drawback means, let's say keys are given 5, so we will map key 5, then 7, then 10, 12, 15, 4, 6, then 20. Here, what is the main issue? Largest key is 20. So the space required is 20. Means array size should be 20, so that 20 can be placed. If the largest key is 200, means or all are empty, means only largest key is given 200. So space required would be, at last index would be 200. So it is the drawback. Means size of the array, in this case maximum size of the array is 20. But if size of the hashing, if size is more than, then hashing size will be also more. If largest key is 200, then hash table size must be of size 200 index. The total 200 index would be there. So it is its main drawback. Means lot of space is required. Lot of space is required means lot of space is wastage. So here is space wastage, we get the term. These are the drawback. So how we will, first this is the key space, we will map to hash table. Here largest key is 20, so I prepared a hash table with index, largest index at 20. So we have to map it. First, this is the, we can take it as a domain and range function. This whole can be treated as a domain and this is range. We will map it. Now we have to map the key space to hash table. Just assume as domain and range. Map domain to range. This domain to range. So here we will assume hash function as h of x equal to x. Okay, we will just map it. Here value of x is 5, so we will map this 5, then 7. I am directly mapping it. Just simply we will put this in a function and we will get the value h of x. We will put this domain value in place of x and we will get the hash function value and we will map it. This is 7, 10, 12, 15, 4, 6, and this is 20. Okay, so this is the function how we are mapping. So what type of function is this? Is one-to-one function. The relational mapping can be one-to-one, one-to-many, many-to-one, and many-to-many. We already know about this. One-to-one and many-one are function. These are function. Function means from the domain how we have to map. That will be, if this side will map to 1, then there will be function, or these are not function, these are relation. So these function we can call it as one-to-one function. This is one-to-one function. One-to-one function. Relation, but this is a function. So here if the largest key will be 200, then we have to prepare a hash table of index 200. So we can know that who is responsible for this drawback? Hash function. Okay, if we want to achieve this in limited space, then we have to modify this hash function. Let's say if I will modify this function, how this space will be reduced. Okay, if hash function is, here take h of x to x mod 10. Previously this function is known as ideal hash function. This is the drawback of ideal hash function, that if in key space large key is there, then we have to prepare a hash table of that large size. This is the problem of ideal hash function. This is ideal hash function and this is little modified hash function. Mostly that hash function will not use, this hash function will use. I am just modifying x to x mod 10. Using x mod 10 in place of x, what will happen? Maximum size of the table will be 9. If we will use x mod 20, then maximum index of the hash table will be 19. For that I am using x mod 10 to limit the hash table. Okay, we will just using this function, we will map it key space to hash table. This start 5, 7, 10 will map to 0, 12, here we see 15. 15 will map to 5, but there is already one element is present at index 5. So this is collision. Okay. In this, hash function will never give value greater than 9 because we are using mod 10 value. Okay. If more than one key are mapped to same place, then it is called collision. Here 5 is already mapped, and due to this hash function we are getting value for 15 as again index 5. This is collision. So this is not ideal hash function. In normal hash function there is a problem of collision, but there won't be any problem in this ideal hash function. Collision problem will not be there because each element of key space have their different indexes in hash table, because we will create that, but there will be issue of space. That's why we are not continuing with ideal hash table. Then this is the problem of collision. So when we have to modify the hash function from ideal to any other hash function, then there will be collision. Then problem is, now we will solve how to solve this problem. So how to resolve these collision. So there are some technique. One technique is open hashing. In open hashing, I will discuss what is open hashing. First, I will write it. Chaining is method. Second is closed hashing. In this open addressing. In open addressing, there are some method. There are some famous method. Linear probing, quadratic probing, and double hashing. Here, open hashing means extra space can be used. We will use extra space. Open hashing means here when collision will occur, these are techniques to resolve the collision. If collision occur, then we will use this method. So here in this example, collision is occurred like 5 is mapped to index 5, again 15 is mapped to index. In case of open hashing, extra space is used, means here space will be used. Here via chaining method we will enhance, means this space will be used with, we will insert extra space, but in close hashing no extra space will be used. About this we will discuss in next video. Thank you for this.